Alright, we're streaming. Waiting for things to get set up. Let's double check some settings. Twitch is a little slow. Alright. Alright, everything's good. So, what we're doing, the point of this stream is to run through a code kata for the factory pattern. I think, as always, it's good to state the goal pretty clearly. So, just the definition of the factory pattern is a creational pattern which uses factory methods to deal with the problem of creating objects without specifying the exact class of object that will be created. And apologies, I am suffering through some allergies, so I'll be making some tea off to the side here. And also got this cough drop, so bear with me. Alright, so we're going to run through a kata to create a factory pattern in C#, using Trilio to manage that. So I'll go ahead and move all the cards back over to the do. And the first step is to create a git repo or burn the old repo and start over. So I got the repo and the link is in the channel. It'll be here. If you came here now and you downloaded it, you'd have the full kata from the previous stream. So what we're going to do first is we're going to commit a deletion of all that code. So I'm going to open the project. And while this is going, I'll just state that the goal here is to commit after every change and using primarily free tools. So if you wanted to follow along and code along, you could. So really only have the one folder here. Delete that. Come to the program and delete the very humble code that we wrote. And then I'll commit this back. And I'll do my best to make sure all these things match up to their names on the kata. So I'll say burn old repo. I'll commit. And I'll sync up. Okay, so now if you went out to GitHub and you pulled it, you'd have a more or less empty project. So let's go back over to our code kata and we'll pull this to done. The first step is going to be to create a simple UI. Pretty simple. So if you're brand new to C#, we created a console project, which gives us a program.cs file, within which is a static void main, which will get processed from start to finish whenever you run the application. So I'm going to do a console.writeLine, give it a hello world. Now if I just ran it like this, it would spit out hello world and then terminate the method and close the application. We want to stop. So we're going to tell the application to wait and don't do anything until it reads a key. So any key press. Looks good. We'll do a test build. Everything built fine. And now I'll debug. Alright, so super simple. Hello world as a UI. We're going to go ahead and commit this with create simple UI and sync it. Alright, so far so good. The easy stuff anyway. Alright, so now that we've got a canvas of sorts to work with, it's time to select a suitable domain aggregate. I've been using the same one in my test streams, and that is a vehicle. And then later on deriving vehicles of different types, so boats, cars, planes. Might change it up in later weeks, but for right now I think it's a pretty good example. I think since a lot of gamers are out there, maybe something that's to do with, race, class, ability, and all that would also be pretty good as for creational katas, but for right now, we're just going to use vehicle. Alright, so let's come back into our project. And some of the way that these folders get structured is just my preference, but since I'm doing domain driven design, instead of my model folder, and any folder for that matter, I like to have a domain folder. And then I will also add one for vehicle. Now inside the vehicle folder, I'm going to start with an interface. And the interface is going to be my contract. It's going to be something that says anything of this type should contain these properties and methods. So anything that calls itself a vehicle should contain what? To keep it pretty simple, we will go with just a name. Oops. And we don't have an access modifier in this, so we public string name with a getter and setter. And then the getter and setter just defines that there's a way to assign this property, and there's also a way to get the value of this property. We're going to use the auto getters and setters for right now. Alright. That's it, really, for that step. And let's go ahead and commit. We'll say select a domain aggregate, which we have done. So it's a bit tedious, but I think it also really helps out if you ever wanted to watch this video later and then also code along. You could go into GitHub and look at the various branches and see the code at that step as it was. Pull it or do as you like with it. Alright, so next step is create an enum for the types. For our factory, we want to create an object, and depending on the type of object we're asking for, funnel it through a switch statement and instantiate a new object. So for that switch statement, we're going to use the vehicle type. So we'll start the class and we'll say vehicle types. We're going to turn this into an enum get rid of some of these using declarations we're not going to need. Then I'm going to say that automotive plane boat. Not super creative, but that's what we'd like for our types to be. All right, create enum for the types. Commit that. I will save it and sync it. All right, so now that we have a contract and the types for our factory, it's time to create some POCOs to feed the factory. This is where the rubber starts to really kind of hit the road, and as a kata, when they all do, they seem so simple, but before you know it, you're going to have 5, 10 files, and you start to see where discipline really comes in handy as far as running through these and getting a good feel for how they should be constructed. So I'm going to create a new class. This is going to represent our automotive type. Now I'm going to do a public access modifier. I'm going to inherit from our contract of iVehicle. So the one tool that I'm using that isn't free is going to be ReSharper. And ReSharper does a lot of great things for you. I think it's about $100 retail, but they've got a lot of open source and student discounts. It's definitely well worth it. I think every shop I've ever been in has insisted on its use. It will make you a better coder if you stop and question why it's telling you to do things. So in this case, it's going to help me out. It's going to say, hey, you're missing members from this contract. So I'll say, great, let me go ahead and implement those. Now, you can't really see this, but it says not implement exception. That's just ReSharper getting a bit handsy with our code. So we got a name as part of the contract, but we also want to have the vehicle type as part of the contract. So let's go back into the contract and do vehicle types, vehicle type. So now we're saying any vehicle that gets created, regardless of its, if it's concrete implementation, must have a name and a vehicle type. I'm going to remove the set on this to say that there's going to be a private set if you want, but otherwise, nothing that's calling this factory is going to be able to set the vehicle type. It's going to be up to the implementation to set it. And if you're brand new to C#, hopefully that will make sense, but it should be kind of self-defining here in a second. All right. So now that I've changed the contract, when I come back into automotive, it's once again in fault. So I'm going to go ahead and implement the type. And so you'll see now that it's only brought in my getter because that's all I have access to. So for get, I want the automotive to always return, excuse me, T time. Allergies. Allergies gods are the old gods. Alright, so I want it to always return a type of automotive. I think this works. So now that we've got automotive, let's go ahead and make the other two. And to avoid ReSharper's funniness, we're just going to type them by hand. They're pretty simple. Alright, so now, again, same thing here. Whenever a plane gets created, it's going to automatically return plane as the vehicle type, and then whatever name we happen to give it. And one more for boat. Boat, boat, boat. Alright, so now we have 3 concrete implementations of vehicle types, and they all inherit from iVehicle, which means they're guaranteed to have both a type and a name. Just to kind of skip ahead real fast, if I came into my program and I said var auto is equal to new automotive, and I gave it a name of Sally. Right, so, well, 2 things. We never actually gave it a constructor to take in the name Sally. So let's go back over to automotive, and we'll say public automotive takes in a string parameter called name, and we'll set the local parameter to that value. So for the constructor, all we're saying is, now the compiler is going to give you a default parameter-less constructor automatically. If you want anything, you have to define it. So that's what we've done here. By defining one with a parameter, you're going to mask the one without a parameter. So, for example, if you still wanted to have the ability to create something without that parameter, you need to define something like that. But that might be skipping ahead. So let's go ahead and do this for the plane as well. And then also for the boat. Alright, so if I come back over to my program, I can do auto is equal to new automotive Sally, and I can also do var boat is equal to new boat, the King James. However, what we've done is we've coupled this instantiation to calling this explicit class, which gives us less flexibility, and it's not always immediately obvious. But what is immediately obvious is that to create 2 objects of the same base type or derived type or contract, we're making 2 different calls, which definitely impacts our readability and the consistency of our code. What we want to communicate with these calls is something about their construction or their creation. And we're not getting that here. There's nothing to say that automotive and boat are related in any way whatsoever. And so it's a small thing, and not necessarily the declared, benefit of the factory pattern, but a big part of all of these patterns is being able to add some consistency, some readability, and ultimately some maintainability to the code. So we want to make this better, and the factory pattern insists it can do that. And like any good pattern, smarter people than I created it, and I will benefit from that wisdom. All right, first, let's go ahead and commit, and we'll try to create some Focos to feed the factory. All right, let's go ahead and sync that up. Going through here, and we completed a task. So, all right, halfway through, not bad. Not bad at all. Alright, so next step is to create a factory wrapper. This is the point of it all. So let's go ahead and come in here and we will create a new item. And we'll call it factory. Just for giggles. Pull the class factory. Now, the trick here is to do a public static method so that we don't have to instantiate a factory or to get access to this. Let's make it create, and we'll return a type of vehicle. Name the method create. We'll take in a parameter of string, and then also the vehicle type. Alright, then we're going to create a switch statement. We're going to switch on the vehicle type. And in the case of it being a automotive type, we're going to return a new automotive and pass in the string name that we got in our method call. And then in the case of it being a vehicle type plain, do something very similar and pass in that name. Case. And then for the last one, boat, return new boat and pass in the name. We're going to give this guy a default as well, just to throw an exception if, for whatever reason, we get a type that we don't have a case for. And say not implemented. Sorry, this type is not supported. We want to do this because on a basic level, we're always creating an API. And whether it's us as coders 6 months from now looking at our own code, or new developers to the team looking at code, things should behave as you'd expect. And somebody passing in a vehicle type that isn't supported is unexpected. So we want to tell them that, hopefully, when they go to compile for the first time, or run for the first time. Okay, so in all of its lacklusterness, that's really the heart of it. So let's go ahead and say we created a factory wrapper. Alright, so next step is to wire it all up. So we'll come back over here. Let's take a look at the 2 lines of code we had before and see how they'll change using our factory. So we're going to say, let's just say var car is equal to factory dot create. So we'll pass it in, and I think the name's Sally. It's a good one. But let's just call it Old Yeller. And then we're going to say that we want it to be of type automotive. And then var, let's just say sailboat to keep things different, is equal to factory dot create. And we'll give it a name of Misty. Alright, so let's we come back to this kind of consistency of the call and creating this API. We don't care how these things are created, we just want the object. When we call these things explicitly here, we're saying we do care how they're created and we'll be in charge of the granularity. Where this will kind of hurt us is when we want to do something like this. If you say, hey, anywhere in my application, whenever an automotive is created, I want to do stuff. Well, that's one change. If you've got 10,000 lines of code, you can make that change very quickly. You can compile it, you can run your test, and you're done. If everywhere that you've created an automotive, you've created a new automotive, and you've then done some more stuff to it in line, then everywhere you've made that change to your auto, you need to now go and change that code as well. There are some other ways to tackle that, but this is the factory pattern. This is the approach that solves that problem that I like. Also because there are things that I might want to do whenever anything is created. Whenever any of these three types was created, the things that I want to do before anything else happens. Shoot an email, log something, do whatever. It also gives me one centralized place for that as well. Alright. So, get rid of this. And I'm just going to call this vehicle picker. And then I'm going to do a console.writeLine. So console.writeLine also gives us access to a string formatter, just baked right in there. Is a so these curly braces and the 0 and the 1s, these are parameters, and then we're going to feed those parameters with our car name and our car vehicle type. Don't need a two-string enum. It's kind of an abuse of it, but it'll go ahead and two-string automatically, even though the primitive type of the enum is an int. So that's why it's an abuse. Other languages aren't quite that flexible with their enums. All right, so for this guy, I'm going to say that the sailboat's name all right, so I got that all wired up. Now, I do usually do the wired up and run the application as one commit, so let's go ahead and do that now. All right, so vehicle picker. Old Yeller is a automotive, Misty is a boat. Doesn't get much simpler than that as far as patterns go. Let's go ahead and commit. All right, hopefully I've profited. Now, as a bonus, before I had done a create a second level to the domain to extend one of the root types. Excuse me. Allergies, do not mess around. All right. But then I thought it'd be neater, a lot more fun, if I started to write a game based only or using only the design patterns I'd covered so far. So every week I will do a new design pattern, and then I'll go see how I can implement that into the game. So let's go ahead and close this out. All right. So completely fictional game with no real interest in ever bringing it to market or anything, but it's at least gives some meat to what we're doing. So I thought it'd be neat if I had a console game called MUD-Z, so a zombie survival game. MUD stands for multi-user dungeon, and the Z stands for zombie, so pretty popular convention. Naming convention anyway. Just a little cheesy Z at the end. So we should see a lot of the same stuff here as far as the factory pattern. I've got a base object called a game object. Every game object should have a name, dexterity, hit points, a game object type, and whether or not it can be destroyed. Now, game object types are player, NPC, monster, inventory item, and environment object. Now, something I didn't show in the kata, but that I have here, is a base game object. So I'm going to allow some built-in functionality for all the game objects. So as before, I would have derived solely off of the contract. Now I'm going to have this abstract class called base game object, and I'm going to allow it to do some wiring up and some basic stuff for me. So right now I just got name, dexterity, hit points, as we know, game object and is destructible. But then I've added two virtual methods called take damage and heal. Take damage takes in a double and then subtracts that damage from the hit points. Not any more complicated or tricky than that. And then heal does the opposite. It contributes to the hit points. So what the idea here is definitely that this abstract says this can't be instantiated on its own. You couldn't do a new base game object. Something has to inherit this, and then you instantiate that. Virtual, on the other hand, says you can override this, but you don't have to. If I made this abstract, then I couldn't have a body, and anything that inherited this method would have to have, inherited this class, would have to have this method explicitly defined. So we're going to go back to virtual. All right. Now, I have a base game object. I went ahead and again, part of the same kata, I chose my domain aggregate being a player. And I decided on player types would be medic, mechanic, army vet, politician, carpenter. I've got an idea for all this. I'll probably write it up as a short kind of like thought experiment, just say something to go off of. But for the meantime, super simple and nothing that's outside of the kata aside from that abstract class. And so inside this domain, I also have a player abstract class. So what we're doing here is we're saying player should inherit base game objects, but it itself should also be an abstract class. So we couldn't just create a new player. And we're going to add a player type, and then these 5 methods that must be implemented for every player. So you can already see where we're starting to branch out a little bit. So we're going to have as far as the game object types, we're going to have a folder for each one of these. And inside each one of these folders, we're going to inherit, or we're going to bind a contract to the game object. And we're going to start defining our types. We're going to start defining our base classes, what those base classes can do, and then also the concrete implementations. So there's, for example, if I've got an environment object, there's no reason for an environment object to be able to negotiate. But again, all objects are going to have a name, dexterity, and hit points. Now, arguably, some things might not be able to heal, but we might change it to something else. All right, so then coming back into player. So now we have these abstract methods in this abstract class called player. We've made one class called medic. Now this is telling me, okay, you're inheriting from medic, but you haven't created any of these required methods. Let's go ahead and do that now. All right. So to give a little more about the game, the idea being that in terms of, here we go. Yeah, in terms of player, every class or every type is going to have 5 possible actions. They can move, they can negotiate, they can heal, they can attack, they can repair. But depending on their class, they're going to be better or worse at each one of these. So this gives us a great opportunity to create a factory that allows us to ask a player to input their name and select a class, and then give them back a player with attributes in line with whatever they chose. When we're getting into the game, we'll see that where it's, well, the army vet can hit harder, but can't really heal for anything, right? Or maybe can't heal at all. And a great example of that would be something along the lines of, let's go ahead and do that. Let's go ahead and say add new item class army vet. Player. Alright, so now that's all fine. Come over here. I'm going to add a new item. Let's call it factory. And to avoid any confusion in the future, we're going to go and call it player factory. Or, yeah, that's fine. We might change that again in the future, but whatevs. Alright, so again, same kata. We're just doing it here, public, static. We're going to make this of type we're going to need a contract here. So we'll call this iPlayer. Wait for my machine to catch up. There we go. And so we'll showcases the need to have that contract, because inside the factory we can't return a player object because it's abstract, and you can't instantiate a new abstract class. So we have to be able to tell the compiler and the system, hey, my return type is going to be something you can instantiate. So give me anything that matches this contract. Player type. And this is exactly as we did it before in our kata. So we've got a medic and we've got an army vet. And you can see where I keep making the same kind of realizations over and over again, which is why they all help. The katas help me as well. I definitely want a public army vet that takes the string name. And then here, player type is in our abstract class, whereas before we had it as part of our interface. This is definitely a pain point for me when I first started learning C#. There's these subtleties that change the example. So I look at one example and then I say, okay, I got it. Go to the next example, and there'd be something just a little off that I didn't track. So hopefully seeing it helps that here. So instead of making, before we pulled this into our concrete implementation, and we said, hey, you're only going to be able to ever be a car. In this case, what we want to do is we're going to say the name is going to be name, and then the player type is going to be Army Vet. So we're going to set that in our constructor. Okay. Oh, look at that. Well then, player. Let's go all the way back. So I had given the name a private set through some copy pasta magic. And so I get back down here and I try to set it. It's telling me that I can't because it's got a private set, which makes a whole lot of sense. Let's go ahead and change that to be just a set. Okay. There's our Army Vet. And now let's do our Medic. Let's change this to Medic. Okay, so instead of our player factory, we're going to turn a new Medic, pass in the name, and the player type. In the case Army Vet, return new Army Vet, and pass in the name and the player type. And then we're going to default, the same thing, throw new not implemented exception. Sorry, this type is not supported. Okay. And we got some red squigglies, so it's not really happy. But we'll come to those in a second. It's a great point. But so far, you can start seeing a game kind of take shape, right? I can get a type of player, and then when I call player.heal, it's going to call the method defined inside Medic or inside Army Vet, depending on which one I choose. So we can start to really branch out in terms of player abilities and roles and classes and all of that. But in our code, it stays very clean. It stays really organized. And there's some better ways to do this. They involve other patterns. So, and again, hopefully the idea will be to do a kata, come in here and apply what we learned, see what the differences are, or where you might want to go off script, and then reconvene. All right. Oops. So this thing is telling me that it only has one, which I believe is the truth. So, all right. Can't convert to iPlayer. That is probably very true. Let's go into iPlayer. So the public interface iPlayer has nothing defined, which explains why, if I went into my factory, it can't convert it to that, because right now, Medic does not conform to the contract of nothing very well. So we want to come back into, and since we did that after the fact, we'll come here, and we're just going to copy all of this and paste it into here. Now, an interface has no access modifiers or constraints like abstract. We're just going to have the return type of any, if any. If it's a method, then the getter and setter and their permission levels. And then also, if it's a method, what the signature should look like. All right. So that feels better. It's still complaining. So, if you come back into medic, the medic is derived from player, and player is derived from base game object, but until now, nothing was derived from iPlayer. So we had to fix that in our medic class. Doing this kind of piecemeal and as we go, because coming from our very basic kata, we're already starting to really code and really hit the ground running. So what if I don't want to put this on every Kafka implementation? I don't have to. I can go back to my player, and I could say, okay, I know player is derived from base game object, and it's going to have all those baked in functionality. But I also want it to conform to this contract of iPlayer. And once I do that to the abstract class, Army Vet, Medic, they all get those things by default. So when I come back into my factory, the red squigglies go away, and the program is very happy. So, and again, in terms of being able to do things in a central location, have the benefits be passed down the line, it's another example of that. All right. So now we've got a player factory, which is pretty cool. Not only do we have a player factory, we've got player types, and we've got some methods that all players should have. We've got some properties that all game objects should have, and we've got at least some stubbed out methods that all players should be able to do. So if I come back into, this is where I'll stop the demo, but because I really want to keep it, I want to make sure that it's at a place where anyone who does the kata can look at this demo and still have an idea of what's going on because I'm too lost. And I think we're trying to stretch that with the inheritance and the abstract classes and all that good stuff. But apologies. If we came back into main and we said var Army Vet is equal to something else a little tricky is that I went ahead and made this a core project. So inside of Visual Studio, I need to reference that project. Wait for my computer to catch up. Okay. And so by referencing that project, I now have access to this namespace, the model namespace. So now I can say inside of core, model, domain, player domain, player factory, create. My name is, I don't know, Gary. And Gary is a medic. Thank you, sir, too. Hopefully it fills a niche. Yeah, I'm trying to explain everything so that it makes sense in terms of the katas that are being done, and then hopefully you can see how all these things are really just a collection of basic principles. And I wish someone was there when I was learning to do something very similar, but man, sometimes programmers are a tight-lipped bunch. All right, so what ReSharper did was it went ahead and put in a using statement, which allows me to call everything up to that namespace directly. So then ReSharper also doled out this code to tell me that, hey, it's kind of redundant or unnecessary. So that's also why we called this player factory instead of just factory. Because when we start creating over here more domains and more factories, and we add in these using statements, the compiler wouldn't know how to distinguish them. We had to start using aliases. If we ever get there by by foolish error or otherwise, for example, I'll explain them. But essentially, if we can avoid that, we want to. Sometimes you can't. Sometimes the DLLs that you're bringing in are going to have namespace conflicts, and you have to use aliases. But if you have the ability to do it properly, you should definitely avoid them. Okay, so what does this give me? What have we done with this factory pattern, with this inheritance, by breaking things up? Seemingly, like, did we really need 1, 2, 3, 4, 5, 6, 7, 8, 9 files just to create a medic? Yeah, sir, too. Keep on watching. Hopefully we'll do some great stuff. So now what I'm able to do, and this is where the pivoting comes in, is I can say, I always call this guy Gary. I know his name is Gary. He's not Army vet. I can say Gary dot. Well, now Gary can attack. He can heal. He can move. He negotiates. I can get his player type. He can repair things. These are all things that Gary can do. But Gary's a medic. So when Gary goes to heal, he's going to heal with the power of a medic, right? If I go into Gary's instantiation and I say, now, you know what? Gary's a carpenter. Well, now when Gary goes to heal, Gary's going to heal with the power of a carpenter, which might be horrible. It might be great. We don't know because we haven't defined the logic for it yet. But what this definitely allows us to do later on is to start expanding, to start changing things, and some things we might want to change on the fly, right? We might want to do some decoration, which is another pattern we'll get into. But when we're decorating, we're going to be giving attributes, taking away attributes. It's things like Gary gets drunk. Well, how does getting drunk affect Gary's ability to heal, right? Or how does getting like a buff spell, how's that going to affect Gary's ability to attack? When buffed, Gary might be, even as a carpenter, he might hit harder than the army vet. We don't know that yet. So right now we're doing this polymorphism, which is a great interview term for junior developers. But we're doing this polymorphism so that on instantiation we can make Gary whatever we want. And then later on when we start getting into the runtime elements of decorators and such, we can say, okay, for just right now, or just for this length of time, temporarily, we want to affect Gary's attributes in this way. So we're going to decorate Gary with a buff spell. Or you know, a drunk condition or whatever have you. So, potentially pretty cool. Or Gary repairs. Presumably, Gary would repair things pretty well because he's a carpenter, but if he was an army vet, you know what? And being an ex-army guy, I'm going to say that there's a good chance the army vet can repair things a little better than the politician, right? So maybe the army vet has a +1 for repairing, but the politician has, like, you know, 0. All right. This part of it was actually a lot of fun, and it's going to take a lot of self-control on my part not to work on this outside of these streams. But what I will do is I'll write up a kind of game bio with what we hope to accomplish, and I'll start working on that as a way of saying, okay, when we get to the strategy pattern, here's how we'll work it in. When we get to the decorated pattern, here's how we'll work it in. With the idea being, at the end of all this, we'll have a game using only what we've covered in these streams. All right, that's it. Thanks to everybody for watching. Surtu, thanks for the feedback, and look forward to seeing you in future streams. I'll be doing this again tomorrow for about an hour, and then hopefully again on Saturday morning for about an hour. And once I figure out the schedule, I'll try to stick to it. All right. You all have a good evening.